Hey, what's up, everyone? It's Hutch here. Welcome to Monday. What we're going to do, first of all, I do want you to see this. It says, if virtual, open me. If for some reason we are virtual, you just click that link at the time that your class says, and you jump on in and we'll say hi to each other. But otherwise, you're going to go to our New Weeks folder. If you take a look at our schedule today, we have weekend discussion, weather, look it up yourself. Click Hutch video link to follow along, which is what you're doing. We're going to do your bell ringer, some 9-7 PDFs, and then you have your IXL EE.8 to complete. Your homework is anything from today that is not finished. So go ahead and click your bell ringers and 9-7, and let's get those to Notability. When you're ready, you can continue this video. So here we are with your week 30 bell ringers. You can go ahead and pause and try out number 1 and 2 on your own, or follow along with me if you need that kind of support. All right, so here we go. Number 1, which bank loan should I take? I'm going to set up I equals capital P, lowercase r and t. My interest amount is unknown, and so my OG principal is 40,000 for both of these. The percentage rate is 2%, but I'm going to do 2 swoops to the left to turn it into a decimal. And it is in years, so we're good to do the 8 years. So that's bank number 1. Let's go ahead and set up bank number 2. And so we have our 40,000. We have swoop, 0.03 for 7 years. Solving those out, we're just going to plug all that right into the calculator. So we have 40,000 times 0.02 times 8. And so our interest that we have to pay, because this is a loan, is $6,400 extra that we're paying, okay, or extra owed. And so I'm trying to think about the situation when I'm making my notes there. All right, let's go ahead and do the other bank and see if it is a better deal. Times 0.03 times 7, and we get, because of that higher interest rate, even though it's less years, we have an interest of 8,400 extra owed. That's crazy. That little percentage really changes things quite a bit. And so if we're thinking about it being a loan, I don't want to owe more. So which bank loan should I take? I'm going to definitely take this bank loan. Okay. All right, let's go ahead and check out the next one. If I got a 60% on a test, which was 80%, how many total points was the test? So I'm going to make my note that this is the part, and I don't know the whole. And so we're wondering a question like 80% of what is the 60%? Okay, and so that's what we're sort of setting up here. Is the 60. And so swoop, 0.8 times x equals 60. And then we'll go ahead and divide by 0.8 on both sides to isolate the variable. We get 60 divided by 0.8, and it lets us know that the test originally was 75 points. So 80% of what whole? 80% of 75 is 60. So there we go. All right, back out of your bell ringer, and let's go ahead to your probability work today. Make sure you're following along. We're in 9-7 simulated problems. I'm going to try to break this down for you to keep it as simple as possible. Really, this is just experimental probability. They're just doing the experiment with a random spinner or dice, things like that, to simulate something happening. And so it's really similar to just experimental probability. And you'll see some of how that's connected. Anyway, what we're going to be doing is reading the questions. They're going to attribute a set of numbers that we'll use to basically run the experiment. And so you'll see what you need to be doing as I go through this. So Molly makes 70% of her free throws. Okay, so this is important information to pay attention to. Actually, I'll highlight it instead. The random numbers below represent 20 trials of simulation of 2 free throws using the numbers 0 through 9. So this is what you need to be aware of. All you're going to do is identify how many numbers they're using to run the experiment. And I'm going to set them up like this for you so you can see. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'd always recommend you writing them out so that you'll be able to see this better. 70% of her free throws are made. So let's have that be the good side. So if you look, because we started at 0, we actually do have 10 numbers here. So 1, 2, 3, 4, 5, 6, 7. This is 70% worth of numbers. And then 80, 90, 100 is the other amount over here. This is my good or made them. And this is no, I did not make them side. Okay, so that's all you're going to do is start off by listing out whatever numbers you're using to run your trial and record down the correct percentage. And I'm just going to do where the negative is first and the positive is higher, but you could do it either way. Okay, so let the numbers from, and this is going to be successful, from 3 to 9 represent successful, which means from 0 to 2 are going to be missed. Based on the simulated results, the probability that she makes both. Okay, so what I'm going to do is I'm going to use my information and identify where she makes both according to our numbers. So making both means a 3 through a 9. So for example, I see a 3 here and an 8 here. That means she made both according to our simulation. Anything 3 through 9. The next one's a no. 3 through 9. This is good, but this one's not, so it doesn't work. 3 through 9, yes. No. Yes. Yes. No, no, no. Yes. 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 No, and no. And what that means is throw number 1, throw number 2. Okay? And they're asking us, where did she make both throws in her 2-shot simulation? And so if we count up all of our circles, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 5, 10, 15, 20. Okay? And so we end up with, I want to double check and make sure I got them all, 3 through 9. Oh, I missed one right here. So just be careful there. All right. So we have 10 out of 20 as the fraction. And that is obviously a 50% chance that she makes both of her free throw shots. Okay. Let's go ahead and slide over here. We're going to do the same concept as we go through this. It says that 80% of people enjoy going to the beach. The random numbers below represent 10 trials of simulation, asking 2 people. Okay, so you can see person 1 and person 2. Okay, they're using the numbers 0 to 9 for the responses. Okay, and so same thing, let's go ahead and list them up here, 0, 1, 2, 3. So make sure you do this as well. 6, 7, 8, 9. And 80% enjoy, so that's 10, 20, 30, 40, 50, 60, 70, 80. So here's my 80% happy and enjoy. And then we have our 20% sad faces, do not enjoy. And what we're going to do is just find out the data of people who enjoy going to the beach versus people who do not enjoy going to the beach. And what they're wanting to know, though, is let's look at what they're actually saying. Asking two people if they enjoy going to the beach. Let numbers from people who enjoy 2 through 9 be people enjoy, which means 0 to 1 do not enjoy. Based on the simulated results, the probability that exactly one of two people enjoy. So we're only, the ones that we're highlighting or circling are the ones where only one of the two people enjoy. So we're looking at sets where only one of them is a 2 through 9. Okay, and so let's see. Both happy, both happy, both happy. Okay, one is happy, one is sad, because one is 2 through 9. Okay, one is happy, one is sad. One is happy, one is sad, and one is happy, one is sad. Okay, and so that's 4 out of 10, or 40%. All right, let's go ahead and take a look at number 8. For number 8, again, let's highlight our information. 60% of registered people vote, so 60 people vote. We're using a spinner, still numbered 0 to 9, okay? And they're asking us what numbers can we use to represent who does vote and who doesn't, or who does and who doesn't. Yeah, I said that right? So same thing, I'm going to go ahead and list my numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to let the higher numbers be the positive, so 60% vote, so that's 1, 2, 3, 4, 5, 60%. So 60% are yes voters, and then we have our complementary there of no, do not vote. Okay, so what numbers can be assigned to represent those? I just listed them. There we go. Based on the simulated results, what is the probability? And here's what we're looking for. At least one person out of 3 does not vote. So we're just looking for, and it says at least, which is important. So it could be 1, 2, or 3. We're just circling any that has no voters. So I'm looking for 0, 1, 2, or 3. If it has that in it at all, I'm circling it. So that has 0, 1, 2, or 3. This one does not. This one does. 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 This one does not. This one does. And this one does. Okay, and so we end up with 2, 4, 6, 8 out of 10. Which is 80% of people, or 80% of our results have at least one person out of 3 that does not vote. Okay. All right. And then number 9, it says inspection of items at a company show that an item has a 50%. So there's my probability number that we're using. Okay. And a spinner with equal size sections 0 to 9, so we're using the 0 to 9 again, are used to simulate the event that the next 2 items are defective. Okay, so that's what I want to find out is about the next 2 items being defective or not. How would you assign the numbers to represent defective and non-defective? So again, I'm going to use the higher numbers as positive, and let's go ahead and list them out. 3, 4, 5, 6, 7, 8, 9. It's 50%. So we have 5 through 9 will be good. And we have 0 through 4, because we have 50%, are bad. So 50% good, 50% bad. Based on the simulated results below, and so they spun a spinner, and there's the results. We want to know what's the probability the next two items are defective. And so they're letting us know what to pay attention to. And what it is wanting to know if we inspected two more items, what's the chance that they are both defective? So I want to analyze how many out of our simulations have both defective. So I'm looking for ones where we have a 0, 1, 2, 3, or 4 in both little double sets there. And so as we go through, we have a double of 0 through 4 there. I have a double here, and double here of 0 through 4. Okay, and so what's the chance that two items are defective? 1, 2, 3, 4 out of 10, or 40% chance, which is pretty high, really. That's not very good. All right, let's go ahead to the next page here. This one has a little bit of a twist because they're giving a lot of different character traits of how they ran this simulation. So let's read this carefully. So first of all, they're using a number cube. So we're dealing with 1, 2, 3, 4, 5, 6 to simulate flower seed sprouting. The success rate they've determined is 50%. And then to make it even more odd, even numbers are success, and then odd numbers are failure. Okay, so they did 8 trials simulating like laying 5 seeds down, and then there's the data that they got. Based on the simulated results, what is the probability that if they put 5 more seeds down, that none of them would sprout? So that's what we're focusing on, is the concept of none of the next 5 sprouting. Okay, so let's look for any of these simulations where none would be a sprout. So we want to write down what is a sprout and what is not a sprout. So even is success. So 2, 4, 6, because remember it's a number cube now. This is success. And 1, 3, 5 is not a success. Okay, they did not sprout. So we're looking for, is there any sets of simulated data with all odd numbers? And as you go through, there's only one right here out of the 8. And so based on the simulated results, the probability is 1 out of 8 for this. And if we put 1 out of 8 in the calculator, you see that is 0.125, or swoop, a 12.5% chance of that happening. So not very big chance. Number 11 is something that we've been talking about. We've talked about before. How is the difference between simulated probability and theoretical probability related to the number of trials that we do? And so see if you can think about what we've done, what we've talked about. And we said the more simulations that you do, okay, is our data going to get closer to the theoretical probability, that actual probability, or is it going to get farther away? What do you think? All right, if you said the more experimental trials you do, the closer we'll get to the actual, then you would be correct. So that's what we're going to write down. The more trials you do, the closer the simulated prob will be to the theoretical prob. Okay. And we could say that with the word experimental probability as well. Okay. The more trials we do, the closer the experimental probably will be to the theoretical. All right. Number 12, suppose Aaron had, interesting spelling of Aaron, had an 80% chance of winning a game. For a simulation, the numbers 0 to 7 are going to represent winning. Okay, so 0 to 7 are winning, and the numbers 8 to 9 are losing. They want you to write 3 different trial results that show 5 wins in a row out of 6 games played. Okay, and so these are just single games. I have to show 5 wins out of 6 games. A win is anything 0 to 7, so I could just do 7, 7, 7, 7, 7. That's 5 wins, and 1 loss will be the number 8. Okay, and there we go. There's one thing. You could have done a whole bunch of things as long as you showed 5 wins and 1 loss. All right, this section here, it says we have about 50% of the people surveyed in a certain county work for a small business. So they're giving you this information. Okay, work for a small business. A random generator was used to simulate the results. They're saying numbers 0 to 4 will be people who work for small businesses, and then 5 to 9 do not work for small businesses. If you want to pause it right now and try A and B on your own and then check with me, go for it. That'll be good practice for you. All right, let's see how you did. So if we look at the information in part A, it says what's the probability that at least one of the next 4 people works for a small business. So we're going to look through our data. We know that 0 to 4, anything 0 through 4 are work for a small business. So we can go through and look at that information. And we're looking, it says at least 1. So if there's even just one number 0 to 4 in there, then they work for a small business. And so it's a yes, yes, anything with a 0 through 4 in it. Yes, 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 yes. 0, 1, 2, 3, 4. No for that. Yes, yes, yes. 0, 1, 2, 3, 4, and yes. So a lot of them. So that means 19 out of 20, which is 95%. Okay, have at least one person that works for a small business. And then part B just says, how would the design of the simulation change if the percent of people who work for a small business was 70%? Well, right now we have it set. Let's go ahead and lay out our numbers. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And what we were doing before is we were having it be 0 to 4, work for a small business. If we changed it to 70% instead, 0 to 4 is 50%. So we would just do 2 more, 60, 70. And this would be our 70% instead. So how would the design of the simulation change? 0 through 6 would be working for a small biz. Okay, 7 to 9 would not. Okay, and so that's the only difference of how you can change the numbers that you're actually going to use for the simulation. All right. That was your lesson for today. Thanks for hanging in there. I know it's way less enjoyable to do it that way. But here we are on to your homework. You have your reteach to build understanding, which is 9-7. This section here is just the example section of what you're doing. This section here is the section that you have to do on your own for homework. So we can take a look at it. They're giving you the percentage. So successful is 80% of free throws. She's using this spinner to simulate her next 4 attempts. The section labeled 1 through 4 are successful. Okay, so 1, 2, 3, 4 are all successful. The section labeled 5 is missed attempts. Okay, based on the simulated results below, what's the probability that she'll successfully make exactly 2 of her next 4 attempted free throws? Okay, and so here is her data, and you're looking for the data where exactly 2, okay, of the free throws are successful. Okay, so for example, if 1, 2, 3, 4 are good, okay, I can see here's a successful and here's a successful. So since there's exactly 2, this is a good one. Go through the rest and take a look. Are there exactly 2 successful? If there are, circle it. And then you're going to create your probability based on how many you have circled. Okay. And so if you look, they are breaking this down quite a bit. So number 1, describe the results of the first simulated trial. Okay. So we're talking about that. Okay. And so describing the results of the first simulated trial, there are 2 successful and 2 not. Okay, so they're having you take a look and notice those things. Now they want you to do the actual findings to find out out of 1, 2, 3, 4, and 5 different simulations, how many have exactly 2 successful and 2 not. And then based on that data, what's the probability that she'll make exactly 2 of her next 4 attempted free throws? So what is the probability of that happening? Number 4, Emma conducts 5 additional trials and records the simulated data below. Based on the results of all 10 trials, what's the probability that she'll make at least 3 of her next 4 attempted free throws? So they're just changing what you're looking at. Now you're looking at least 3 means that you're going to circle it. So take a look at that, but also pay attention. They want you to use these 5 down here and join them with those ones up there. Okay, so something you could do even is take these, copy, and we could even put them down here for you to like analyze them together. Okay, because it is asking the result of all 10 trials with this new focus. All right, so that is your homework. Once you get that done, if you take a look at Schoology, it says to go to IXL EE point 8 and complete that. Anything not finished is your homework today. All right, good luck. If you run into trouble, send me an email and let me know, and I can help you out.